So this is our last unit in the chemistry portion of physical science. And so we're just going to do a couple of small overviews of a few different units, which you will see moving into chemistry. This way you kind of have a basic understanding of these concepts like solutions, which we've already talked a little bit about in our reactions unit and previous units as well, acids, bases, nuclear, things of this nature. So let's start with solutions because I think that our material flows best into the solutions concept since we've already learned what a solution is way back in Unit 2. We learned that it is a homogeneous mixture, meaning that it has been that mixture is evenly mixed. The solute is the substance being dissolved, and the solvent is the substance doing the dissolving. So the way I like to think about this is solute dissolves in solvent. So solvation occurs at the surface of the solute. The solvent particles are going to surround the solute particles, and the solute particles get pulled into the solution. So let's see if we can't draw a picture to help demonstrate what this actually looks like at the particle level. So if I have sodium chloride, NaCl, our table salt, now reminder, this is an ionic compound because it has a metal and a nonmetal. It is made up of our ions, our sodium cation and our chloride anion, so it will dissolve in water because ionic compounds tend to be soluble in water. So what happens when I put salt in water? The water actually physically surrounds the sodium chloride. Now, I have a polar substance here. H2O is a polar substance. So electrons are being shared unevenly between the hydrogen and the oxygen. This uneven sharing is what causes our sodium chloride to separate. Sodium is made up of a sodium cation and a chloride anion. So what happens is because of this unequal sharing, there is an attraction between the oxygen in water and this sodium ion. So we see it gets pulled apart. And there is an attraction between the hydrogen of water and this chloride ion. And you're going to learn a lot more about what this process is and in much more detail when you move to chemistry, okay? But for the purposes of this class, water is attracted to the sodium ion and the chloride ion, pulling them apart. Now, in order to get things to dissolve, solids are going to dissolve faster if I have an increase in stirring or shaking. A small particle size will also help because there is an increase in surface area. So the more surface area there is, the more water that can surround it, the more water that surrounds it, the more attraction, the quicker it dissolves. Stirring, again, is going to put more water around it, all right, in causing it to separate, as well as some other things, which you'll talk about when you talk about this in chemistry next year, all right? You'll go into more detail. There's some other things involved as well. Again, a high temperature as well. All right, so a high temperature increases the kinetic energy of a substance. Think back to our previous units. All right, so a higher temperature increases kinetic energy. Kinetic energy is the energy of motion. More motion causes more collisions, and it pulls these apart quicker. So more motion, we have a better surrounding of water, and then it also has to do with the number of collisions and some other things. You'll talk about that in chemistry, but it will help to pull apart and dissolve faster. Gases are opposite of solids. They actually dissolve faster if there is no stirring or shaking. When the pressure is high and at a low temperature. All right, so a low kinetic energy. And why this works, again, is well beyond the concept of this course. This is something you will review, or you will go into much more detail next year when you take chemistry. All right, so our solutions are based on the state of that solution. The solute and the solvent must have similar properties. So properties have to be very similar in order for dissolving to occur. Dissolving can happen with any combination, a solid, a liquid, or a gas combination, any type of combination. So let's talk about if you've ever had a filling. All right, so a filling at the dentist is an alloy of silver and mercury. Mercury is the liquid, silver is a solid. All right, so mercury is a liquid at room temperature, and silver metal is a solid at room temperature. So, but mercury here is going to be the solute, and the silver is going to be the solvent. Remember, solute dissolves in solvent. So the liquid is actually dissolving in the silver solid to create a solution which solidifies. It's a solid, and now your tooth has that filling in it, all right, and it's nice and hard. Another example would be air. Oxygen and other gases are dissolved in that nitrogen gas within the air, okay? So we have a gas solute and a gas solvent making a solution of air, which is also a gas. So we have a lot of different gases around us. Let's talk about oxygen in water that fish are able to breathe. So fish breathe oxygen, but the oxygen is actually dissolved in that liquid water. Oxygen is the solute in this case, and water is the solvent, which is a liquid. So we have gas dissolved in a liquid solvent, but the overall solution is a liquid. Now, when we talk about similar properties, what we mean is like dissolves like. All right, so what we've talked about in our previous units, we've already learned that nonpolar is an equal sharing of electrons, and our 7 diatomic elements are nonpolar. Polar is an unequal sharing of electrons, and polar tends to happen when you have 2 different elements in a compound. Of course, if you'll remember, I said this doesn't always hold true. You'll explore that in more depth next year, okay? But in general, our purposes, nonpolar, 2 of the same element. So nonpolar has to dissolve in a nonpolar substance, and polar has to dissolve in a polar substance. And this is why oil and water do not mix. If you've ever put oil on water, you notice that the oil floats on top of the water. Now, the oil floats on top of the water because oil is less dense than water, but they also don't mix because oil is nonpolar and water is polar. So how does soap work? Soap works because it has both a polar end and a nonpolar end. The nonpolar end is going to actually dissolve the dirt and grease on your hands. And the polar end is going to dissolve in the water to remove the soap from your hands. So we have the non-polar end that removes the dirt and grease, and then when you run your hands under the water, the soap washes off because the polar end of the soap dissolves in the water, removing it from our hands.